This is section 4.3, division of polynomials. Our simple form of division is division by a monomial. A monomial is simply a polynomial with one term. When I want to divide a polynomial by a monomial, I can write it as a fraction, in this case 6x to the fourth, plus 3x cubed minus 6, all divided by 2x squared. I can then split each term in the numerator and divide it separately by the denominator. So this becomes 6x to the fourth over 2x squared, plus 3x cubed over 2x squared, minus 6 over 2x squared. This now allows us simply to apply our rules of exponents. 6x to the fourth over 2x squared, 2 goes into 6 3 times. X to the fourth divided by x squared is simply x squared. 3x cubed over 2x squared simply becomes 3/2 x. And I can reduce negative 6 over 2x squared to minus 3 over x squared. Our division algorithm for polynomials is simply your division algorithm for regular division. We're going to take two polynomials, f of x and d of x. Okay? F of x is your dividend, and you're going to divide it by your divisor. So if you're looking at it as a fraction, your dividend would be your numerator, your divisor would be your denominator. F of x equals d of x times q of x. Q of x is how many times d of x goes into f of x. And then your r of x is your remainder. Let's go back a long ways and see if we remember how this is done. Remember when we took long division, we took 16 and divided it into 92? We sat there and said 16 goes into 92 5 times. 5 times 16 is 80. We subtracted. We got a remainder of 12. So 92 divided by 16 was 5 plus 12 over 16. Your 92 was your dividend. Your 16 was your divisor. Your 5 was your quotient, and your 12 was your remainder. We wrote it this way, 92, there's my dividend, equals your divisor times your quotient, your divisor times your quotient plus your remainder. Let's expand this now. Let's look at it in terms of polynomials, and this is the technique we're going to need to use when we have polynomials with two or more terms. This will work with binomials, trinomials, etc. What we're going to do is we're going to do long division. I'm going to take this fraction, 5x cubed minus 6x squared, minus 28x minus 2, and divide it by x plus 2. So I'm going to put the x plus 2 out front and this polynomial underneath my divisor bar. Now, if you remember when we did our division, we said how many times does 16 go into 92. We have to do the same thing here. When we do our division, we're not going to worry about the x plus 2. We're just going to worry about the term out front, the x. And we're going to ask ourselves how many times does x, in this case, go into 5x cubed. And we say how many times does x go into 5x cubed? The answer is simply 5x squared. We simply do a quick division. 5x cubed divided by x is 5x squared. Now just like we did here, we sat there, we said how many times does it go in, then we multiplied. We're going to do the same thing on this screen. X goes into 5x cubed, 5x squared times. I'm now going to take this 5x squared and multiply it by our divisor, the x plus 2. So 5x squared times x is 5x cubed. 5x squared times plus 2 is 10x squared. And if you remember, once you multiplied, you subtracted. So I'm going to subtract this entire thing. So 5x cubed minus 5x cubed is 0x cubed. Negative 6x squared minus 10x squared is negative 16x squared. This is the point where a lot of students will mess up on, is they'll forget to do the subtraction. They'll simply add them. You have to subtract this bottom from the top. Now, just like we would have to bring down in prior division problems, we also have to bring down here. The rule of thumb for bringing down is we look at the divisor. We have x plus 2. There are two terms here. Remember, terms are separated by plus and minus signs. So there are two terms here, which means there has to be two terms here. I subtracted and got the negative 16x squared. I'm going to bring down the negative 28 now. The negative 28x. Now I have my two terms. Now I'm going to refocus. I'm going to go back to the x in my divisor. I'm going to ask myself how many times does this x go into the negative 16x squared? Well, x goes into negative 16x squared, negative 16x times. That is where I start repeating myself now. Negative 16x times x is negative 16x squared. Negative 16x times positive 2 is negative 32x. And this basically winds up giving me my new line that I have to subtract. Negative 16x squared minus 28 minus the quantity negative 16x squared minus 32x. Negative 16x squared minus negative 16x squared should be 0 if we did this right. Negative 28x minus negative 32x is 4x. I need another term to bring down now as well because I have to have two terms. So 4x minus 2, and we do the whole thing again. How many times does x go into 4x? Goes in 4 times. 4 times x is 4x. 4 times 2 is plus 8. Again, we subtract. Again, this is all an algorithm, the same set of steps over and over again. And then we wind up with negative 10. The question is, how do we really know when we're done? Well, we look at the x plus 2. X plus 2 is a binomial of degree 1 because the x has an exponent of 1. Whenever this thing down here gets less than that degree, we stop. Negative 10 is a constant term, which means it's degree 0, so we are now done. We don't have to divide anymore. That means that quotient is this up here, the 5x squared minus 16x plus 4, and the remainder is negative 10. Now, there are other ways to divide. A shortcut to long division is what's called synthetic division, and it can only be used when we divide by x minus k. Okay? In other words, I can't have 2x minus k or 9x. That coefficient in front of the x has to be 1. What we're going to do with synthetic division is we're going to sit there and make 3 rows. In the first row, we're going to write the k. Okay? Notice this is x minus k. We do the opposite of this. We write the k. Then we'll write all the coefficients of f of x, those numbers out front. We're going to include zeros for any missing terms. We're going to leave the second row blank to start off with. In the third row, we're going to take that first leading coefficient and drop it down. We'll call this our column 1. We're going to take that number we started with in column 1 and multiply it times our k and put it in column 2, row 2, and then we're going to add. And we're going to keep repeating this until we're done. Let's see how this works. This is the same problem we had before, the 5x cubed minus 6x squared minus 28x minus 2. We can do synthetic division because the coefficient of this x is 1. So x plus 2, my k is negative 2, so I put this up here on the far left. For synthetic division, this is x cubed, the coefficient is 5. For x squared, the coefficient is negative 6. For x, the coefficient is negative 28, and I have minus 2. So for 5, negative 6, negative 28, negative 2 go on the top. I skip the second row for now. I go down to the third row, and I drop down to 5. That's my starting point, okay? Now I start my synthetic division. 5 times negative 2 is negative 10. That now goes in the next column on the second row. I now add, you get negative 16. Negative 16 times negative 2 is a positive 32. That goes in the second column on the next row, the second row on the next column. So negative 28 plus 32 is 4. Repeat yourselves again. 4 times negative 2 is negative 8. Negative 2 times negative 8 is negative 10. I now have our answer. This was a degree 3 polynomial. When we divided by a degree 1, our answer should be degree 2. So this becomes 5x squared minus 16x plus 4 with a remainder of negative 10. So I divide, there was my quotient, 5x squared minus 16x plus 4 minus 10 over x plus 2, which was my remainder. And this matches up with what we did on the long division earlier. Just remember, you can only use synthetic division if the coefficient of x is 1.